Okay, let's take a look at problem 1. First, let's look at the definition. Rate of change shows the relationship between changing quantities. When one quantity depends on the other, the following is true. The rate of change is the change in the dependent variable divided by the change in the independent variable. So, another way of thinking about this is the change in y over the change in x. So, finding the rate of change using the table. It says marching band. The table shows the distance a band marches over time. Is the rate of change in distance with respect to time constant? What does the rate of change represent? So we have distance, change in distance over change in time. So we're going to calculate the rate of change from one row of the table to the next. So first they did, and it's the difference. So we're going to the second minus the first. So 520 minus 600 as the distance, and then the corresponding time 2 minus 1. Then the same here, 780 minus 520, and the corresponding time 3 minus 2. And then 1040 and 780, and the corresponding time 4 minus 3. And each time we got the rate of change is 260. So 260 feet per minute. This represents the distance the band marches per minute. Alright, so let's look at the guided. It says, do you get the same rate of change if you use non-consecutive rows of the table? Well, non-consecutive means that they're not beside each other. So if I choose, let's say, 1040 and 520. Let's see. Let's check it out and see. So rate of change. And it was going to be 1040 feet minus 520 feet, and that was at 4 minutes minus 2 minutes. And we can use our calculator. We get 1040 minus 520, which is 520. And 4 minus 2 is 2 minutes. I need to reduce that as much as I can, so I'm going to divide, and I get 260. So I get 260 feet per minute. So it is the same, so that means that it's constant. And I hope that this helps.